Hello everyone, I'm Jivika Kancharla and today I'll be explaining you guys the solving of second question in homework 11 of the course Probability and Stochastic Processes. Now before we look at the solution, let's have a quick look at the question. So the second question is, it is suggested that the following functions of v, that is a, f of v is equal to e power minus mod v, b, f of v is equal to sine square v by v square, c, f of v is equal to 1 when mod v is less than or equal to alpha, and 0 when mod v is greater than alpha, may represent an autocorrelation function of White-Sands stationary stochastic process by setting v is equal to tau, or a spectral density function by setting v is equal to w or both. Which functions, that is the given three functions, f of v may represent either both or it can either represent any. We are also asked to explain our answers. So now let's have a quick look at the solution. If r of tau is autocorrelation function for real and is also a White-Sands stationary stochastic process, then x of t it is even and r of tau is less than or equal to r of 0. Therefore, it's a Fourier transform, it's non-negative. Also, if SW is a power spectrum of White-Sands stationary process, x of t, then it is non-negative. Now here we are given three values of f of v for which we have to check if it is an autocorrelation or not. Therefore, f of v is equal to e power minus mod v in the E1. It may be autocorrelation as e power minus mod v is even and e power minus mod v is less than or equal to e power minus mod 0. And e power minus mod v is non-negative or interlinked with 2 power alpha by alpha square plus w square. Therefore, this value is non-negative. In the B part, we are asked about f of v is equal to sine square v by v square. It can be an autocorrelation because sine square tau by tau square is even. And also we know that sine square tau by tau square is less than or equal to limit tau tends to 0, sine square tau by tau square is equal to 1. Therefore, we can represent this in a graphical form where from -2 to 1 it is increasing and from 1 to 2 it's a decreasing graph. Therefore, sine square tau by tau square is also a non-negative. Therefore, it may represent a power spectrum also because sine square tau by w by w square is greater than or equal to 0. Now in the C part, f of v is equal to 1 when mod v is less than or equal to alpha, and it is 0 when mod v is greater than or equal to alpha. It cannot represent an autocorrelation function because its Fourier transfer is 2 sine alpha w by w. Therefore, it is not non-negative. It can be a power spectrum also because f of w is greater than or equal to 0. Therefore, in the second question, A, it can be an autocorrelative and it is non-negative. And in B, it can also be an autocorrelation and it is also non-negative. And C, it cannot be an autocorrelation and it cannot be non-negative. That's it. That is the solving of the second question. And here we've pretty much solved everything. Therefore, A is both autocorrelation and non-negative. B is autocorrelation and also non-negative. And C is neither autocorrelation, neither not non-negative. Therefore, this is the solving of second question. Thank you.